your batteries the same way. On this side, what are the three things I need to have? Anode, oxidation, and negative, because being ran over by an ox is a negative experience, right? Okay, other side. What are we going to put on the other side on the right? Reduction, cathode, good, and positive. And the key is red, cat, pause. Okay, good. All right, Dan, what else do we have on all batteries that we can put in? Salt bridge, good. So we're going to put a salt bridge in. We're going to label it. No, it can be down below. I just did that because I didn't leave much room here. Then I've got to show that my cations are heading to my cathode and my anions are heading to my anode. Okay, so each of the things I've added up there are 1 point each. Okay, then I show that I have a little water in here and in here. And then what do I need to put in? I need to put in an electrode. I haven't identified what it is, and I need to have a place for my ions. So an electrode and an ion. Yeah. You really, in order for it to be a wet cell, you really should have water, because otherwise the ions can't transfer. Okay, so now I look at my reduction table, and I find gold and I find iron. Now, iron's much lower than gold, so because gold's on top, it gets the reduction side, since this is a reduction table. So it's going to be gold, and gold plus 3. And then my equation here is AU plus 3 electrons yields AU, that's a point. And my voltage is 1.5 volts. That's a point, yes. If they've labeled it backwards from what I have, it's fine. But if they haven't, then yes. Does that make sense? So they could have put gold on this side and labeled it red, cat, pause. And the other side, the other, but yes.
We miss multiple points if we did it backwards or just one.
If you did it completely backwards, if they put reduction on this side, but if they did this side inside, you either lose the 6 on the outside or you lose what's inside. The inside. Okay, but they've got to have these the right direction too. So you got to decide. Okay, so on the other side, since Fe is lower, it's going to be backwards. So we're going to we'll have Fe here and Fe2 plus here. But then we go from Fe to Fe plus 2 electrons. The voltage changes sign, so the voltage for this is 0.44 volts. At that point, we can add the voltages together and get the E cell, which is 1.94 volts. This one flips sign. It was negative, but we changed the equation. Okay, you also get a point for telling me that this one gets smaller and goes off in, and this one gets bigger, and so it's coming out of solution. What else am I missing? The voltmeter. So I got to put a voltmeter up here. That's a point. And I've got to connect it. That's a point. And I've got to have the electron flow, which is going this way. Okay?
Well, I didn't hear the going from electrode to the water and then going like this.
So each of the things I wrote on there are 1 point. So you've got a total of 20 points. Score it and hand it back. Okay, we got a couple of things today you picked up as you came in. We have redox and electrochemistry review, and you have a battery inquiry lab. We're going to work together for a minute on the redox review. So if you get that out. see if we can bring this up a little bit. Okay. So what we want to do with this one, okay, this is really simple. We've done all this stuff before. It might look like we haven't, but we have. Okay. What we're doing here is we're just looking at our yellow sheet, our reduction table, and seeing in my reduction table, does this go to this? Is there any place that goes to that? Yeah. Anybody find it? You better not find it. Why? Silver is part of our slide. What's its charge always? Can it be a positive 2? So is this reaction spontaneous? Will it happen on its own or will it not?
What is
Spontaneous means it will happen on its own. Not spontaneous, it won't happen. No, because I never make silver plus 2. So this one's going to be a no. Not spontaneous is written. Okay? Let's look at this next one. Let's find gold, and let's find iron plus 3 going to iron plus 2. You will be able to find those two on here. Let's find them real quickly. So gold we know is at the top, right? Where is iron 3 going to iron 2 plus? It's part way down, about where my thumb is. Can you find it? Okay, so which one's on top? Gold. So up here is it written like what we've got here? Is AU plus 3 going to AU? No, it's backwards, right? This AU going to AU3 plus is backwards from what I've got on my chart, right? So that means I flip that sign. So it becomes a negative 1.50. And what about the FE? FE3 plus going to FE plus 2. Is that how it's written on my chart? So I'm going to take that just as it is. Okay? So I'm going to add those two together. What am I going to get? Negative 0.70 what? 3 volts. If it's negative, that means it's what kind of battery? Voltaic or electrolytic?
no?
Electrolytic, because it needs electricity. It would need to have a generator hooked up. So is this spontaneous as written? Will it happen without me doing something? No. So this one is not spontaneous. Can you see this is the same stuff we've been doing? Yes.
So is that how you get a rechargeable battery?
Yes. So if I set it up like this, I've got to put a generator, I've got to plug it into the wall to force electricity through that direction. Okay? It will be spontaneous if I turn this arrow around and instead of here I did this. That would be spontaneous.
And that's what you're actually using.
That's when I'm using the battery, yep.
So spontaneous when it does it on its own. And
Right, and I would have a positive voltage. Voltaic will be positive voltage, and that'll be spontaneous. Electrolytic will be negative voltage, and it won't be spontaneous. Okay, so I'm going to leave the next one for you to do. This is the same setup. This is just what we call a battery notation. So I'm just looking for CD going to CD plus, actually let's write one. So we haven't written one, and there's one more after that. So it wants us to do a voltaic, which means what? Positive voltage. So I'm finding both of these on my chart. Find both of them on your chart. What one's the top one? Cu. So Cu is Cu plus going to Cu metal. And that one is going to go Cu plus to Cu metal, right? And I'm going to just write this like this. Plus an electron goes to Cu metal. And what's the voltage on that? Okay, 0.52. And that's the top one, so we're going to leave it that way. What about the bottom one, CD? And that, since it's bottom, we're going to flip that equation, right? So it'll be CD goes to CD plus 2 electrons, right? And it was what? And I'm going to add those together to get E cell, which is what? 0.92 volts. Okay? Yes?
So is CU parentheses S? Second one, like,
Cu parentheses S.
so
So it just means solid. S just means solid.
in the notation, the second CU
Yeah.
is not a plus. So
This one is just the solid. Okay, so now it wants me to write the overall cell reaction. This is not the overall cell reaction because I don't have electrons in my overall cell. I've got to be able to cancel them out. So the arrows are like the equal sign that we have in math. Okay? So the arrows are like the equal sign. I need these electrons to be the same. So I'm going to take and times this top one through by 2 so my electrons are the same and will cancel out. Okay? Yes? You can, but you got to be able to cancel it out and rewrite the equation. So I like to do that and then just cancel it out like that. Okay?
So where can I find more stopwatches?
They will be in this, not this first aisle of second aisle. They might have them out. Because we had 2 big,
There's only 1 box in there.
they might be using them.
Okay. And then what size of graduated cylinder? Just the 10
10
milliliter?
milliliter.
And then what size of the beaker?
Do they need a beaker? I don't think they need a beaker. Yeah, I don't think they need a beaker. Okay, so all we're going to do now is we're going to add these down. So it would be 2Cu plus CD yields 2Cu plus CD plus 2. Done. So you treat this like an equal sign. So it's like an equal sign. Anything on this side I write, added together, equal, whatever's on that side left over. It's just like a math equation. All I'm doing is canceling out my electrons. But this 2 doesn't affect this. Okay? Yeah, you have to put the charges. Okay, so you guys are in charge of B on that one. Okay, let's talk about these others down here a little bit farther. Down. This is a review. Yes. Okay, so let's look at this one, number 4. We did this last time. Remember Leo the lion says grr, or oil rig? Leo, we had loss of electrons is oxidation. Grr, gain of electrons is reduction, right? Or oil rig, oxidation is loss, reduction is gain, however you want to remember it. What is this SN1? Is it gaining or losing electrons? It's gaining. Gaining electrons. So which one is it? Reduction. So you just write reduction. What about this next one? It's losing electrons. So oxidation. Okay? We talked about what an electrolytic cell was just a minute ago. What is it? One that's powered by a generator. One that I have to force to happen. One that I have to plug into electricity to happen. What is a voltaic cell? Focus. Come on, stay with us. What is a voltaic cell? Spontaneous will happen on its own. It gives me voltage. Okay, so electrolytic, I have to put energy into. Voltaic, I have to, or it gives me voltage. Okay? All right, so what are dry cells? Dry cells are the batteries we carry around. Because if we had to have water in them, like the batteries that we've been showing and drawing, like in cars, that we had to carry it around, those are wet cell. Dry cell are the ones that we can just carry around and they don't spill. Okay, that's what a dry cell is. So dry cell is a battery, just a portable battery, like an AA, a C, a D, AAA, or even button batteries are dry cells. Okay. On the next slide over here, we talked about Leo already. What was Leo? Loss of electrons is oxidation. Good. Okay, now, determine the oxidation state for each of these. This is going back to what we first learned with how do we figure out what charge something has, right? So if I have H2SO4, H we already know. What's H all the time? Plus 1. So I can write in there plus 1. What's oxygen most of the time? Negative 2. Good. So I have here 2 plus 1s plus, I don't know what sulfur's taking, plus 4 negative 2s. And what does that have to equal? Always 0. Has to equal 0 because it's a formula that doesn't have a charge. If it has a charge, then I'd put it equal to its charge. So now I go, okay, well that's 2 plus x minus 8 equals 0. Oh, that's x minus 6 equals 0. X equals 6 plus 6. Done. Okay, so I'm just trying to find out what the charges are. That's it.
Okay, so that's
For how many I have right here.
why wouldn't S just
Okay, S is where is a, it's a group, no, well, okay. S can have many charges. Oxygen, if it's forced to with columns 1 or 2, it can have different charges, but that's the only thing that could force it.
so will oxygen always be?
Yes. I'm not going to give you any funky ones. Unless I give you H2O2, which then oxygen has to be negative 1. Okay? All right, so let's go down to this next part. Then we're going to hopefully get back to lab here pretty quick. Whoa. Okay, on this next part, all you're going to do is identify the charges. Okay? So just like we did up above, we're going to find out what the charges are. Sodium, what's its charge? Plus 1. Tin, do I know what tin's charge is? I don't know what tin's charge is, so I'm going to have 2 times 1 plus x plus, what's oxygen's charge? Negative 2, and I have 2 of them. So that's got to equal 0. So 2 plus x minus 4 equals 0. X minus 2 equals 0. X equals 2. So that's a plus 2. Now this one right here, bismuth. Well, I know hydroxide is what? What charge is hydroxide? All the time. If I don't remember, I look on the back of my periodic table. It's a minus 1. I have 3 of them, so bismuth has to be what charge? Positive 3, good. But I want each of these individual charges. Well, oxygen's a minus 2, hydrogen's a plus 1. Any element that's left by itself, its oxidation state is 0. So that one's easy. Sodium, here we got sodium again, plus 1. Tin, it's a different tin than over here, so I got to figure it out. Oxygen's a minus 2, so I've got 2 plus x plus 4 times negative 2 equals 0. 2 plus x minus 8 equals 0. X minus 6 equals 0. X equals 6, so plus 6, right? Hydrogen plus 1, oxygen minus 2. Now, I got to figure out what's changing side to side. What elements change charge from one side to the other side? SN, okay, SN changes. It was a 2, and now it's a 6, so it changed. What else? No? What else changed side to side charge? Bismuth, good. It went from a 3 to a 0. Which one became more positive? Tin. So if I became more positive, did I lose or gain electrons? I lost electrons. Leo, which means I was oxidized. What about bismuth? Grr, I was reduced. Okay, you're going to do that for this next one. If nothing changes side to side, it is not a redox reaction. We didn't talk about RA and OA, so I'm not having you do that. So I just want you to identify what's reduced and what's oxidized. So I cut out part of the instructions there. We're shortening this unit because we need to get to other things. Okay, backside. On the backside, we have got a battery that you need to practice doing. So you're going to have a battery or two. We talk about GER. What was GER? Gain of electrons is reduction. So we can write that down. What does redox mean? Remember I sort of told you it's sort of like a marriage. I got to have a bride and a groom. In redox, I have to have reduction and oxidation, so we shorten it and just say it's a redox reaction. Instead of shortening a bride and a groom to a wedding, we shorten reduction oxidation to redox. Yes. Gain of electrons is reduction. Okay. A battery has to have a reduction and oxidation. I've got to have somewhere that's taking the electrons and somewhere that's giving the electrons. Otherwise, it doesn't work. So the next one right there, you are going to set up. Okay, just like we did for the quiz today, I reprinted that little reduction table off to the side so you can do it. You're going to be setting up a battery. Now, know that I will probably also, remember I told you I'd give you the two types, a battery and a electrolytic cell, so one that would have a generator like your dry lab that we did last time. So what's the difference between the two? How do I do them different? Generator, I flip the top one instead of the bottom one on my chart, right? And I have to have a negative voltage. Yes?
When you're looking to see which one is on top,
Mm-hmm.
you want to look for the actual metal, so not
Doesn't matter which one it doesn't matter which one you look for, because whatever it goes to, it has to have both sides.
Because in the quiz, I was looking for F, and I looked at the Fe+2.
Right, but then you got to look at what else it is. It's on. You got to make sure you have both sides of it. So if there's more than one equation, I will give it to you like this.
Oh, as in that's what should.
These two go together. So if there's more than one equation, I'll give it to you like this. Does that make sense? And then that double bar that's between them just means I need a salt bridge between them.
So with this
Okay.
one, is there only 1S and 1K?
Right. Okay, any questions with the review? The long quiz, short test next time is going to be just like this. With the exception is you'll have two batteries to do. Well, one battery and one electrolytic. Okay? So now we're going to look really quickly at your battery inquiry lab that we're going to go back in lab and do. So get that out in front of you.
Is this something due today? This one that we did last
Yeah, the one that we did last time is due today. Okay. First up, I want you to change something really quickly for me. We're going to do nickel instead of lead. Nickel is a little bit less harmful, and we don't have to worry about lead poisoning. So cross out lead and put nickel where lead is on your lab. Okay? This is a fairly easy lab. You're going to need, your partner and you are going to need a calculator to take back. When you get back there, let me borrow yours real quick. When you get back there, this little square hole here, there's an easy link that you plug into here. And then into the easy link, you plug in your voltage probe. Okay? And when we get back to lab, I'll show you how to use the voltage probe. Okay? You're going to have a set of electrodes there. Whatever you, Grayson. Okay, whatever you have at your station, whatever fruit or vegetable you have at your station, that's what you're going to test first. And you're going to find the best combination of electrodes, the one that gives you the highest voltage in your fruit or vegetable. And then you're going to go around in the bottom part and test all the fruits and vegetables with that combination. Okay? Now, when you go back there, some of the electrodes are very bendy. So you'll want to use iron to make holes into your vegetable or fruit so you can put the other electrodes in. because iron's pretty stiff and strong. Okay, yes. No, you'll need to borrow that other one because it has probe wear that goes with it. It should automatically turn on once you put that probe wear link in. It'll automatically bring up the program and show you the voltage, which is awesome. Okay, yes. You won't need goggles because all we're doing is playing with fruit and vegetables. I think you guys are okay with that. Okay, so once you get done, please don't forget your conclusion. A lot of you are forgetting your conclusion. What did I learn and what were the possible errors? Okay, so let's go grab our stuff, grab a calculator, and head back to lab.